So you can see yesterday I gave you this question. Like we completed the discussion about electrostatic potential and potential energy and the electric field. So we did all these kind of things, isn't it? And then I gave you this question. So try to do it. Did you have done it? Then try that. Okay. Then I'll move ahead. Yeah. Okay. Let us first find. Do the calculation of. Let us do the calculation of electric field. Then you do the others. Okay. So E means electric field at point A. Electric field and potential at A. Okay. Now at A, Acha, I gave this as minus Q. One minute. Sorry. Just make it plus Q. We have two similar charges. Okay. So look over here. If I consider just plus Q, I have considered minus Q because you can take minus Q also. But here in the book plus Q is given, so that's why I am taking plus Q. Okay. You can change. You can change. Definitely, you can change. No, second question is minus Q only. Okay. Ah. So look over here. When I consider about the electric field and potential at point A, means let's suppose this is my charge. So see that on A due to this charge, due to this, let's suppose I call this as charge C and this as charge D. So the electric field will be towards this side due to charge C, and due to charge D, the electric field will be towards this side, and this electric field will be 1 by 4 pi epsilon naught q by 4a square, and this will be also same 4a 1 by 4 pi epsilon naught q by 4a square. So both of these electric fields are equivalent, means magnitude wise they are equivalent and direction wise they are equal and opposites. So that means E net at A is equal to how much? 0. Are you able to get me? So net electric field at point A is how much? 0. Now if net electric field is 0, the potential, so second thing I have to calculate is potential. Now potential is not a vector quantity, isn't it? So potential at point A will be potential due to charge at C plus potential due to charge at D, isn't it? So that will be equal to 1 by 4 pi epsilon naught. I'll take 1 by 4 pi epsilon naught common. Charge at A is Q and distance is 4A, plus charge at D is Q and distance is how much? 4A. Right or not? If any of the charges would have been negative in potential case, you were required to take the sign. Right or not? So this gives us this implies potential at A is equal to twice means Q by 8 pi epsilon naught into A. This is going to be my particular potential at A. Are you able to get me or not? Yeah. Now it is asking the electric field and potential at point B. This calculation they are asking, isn't it? So simple. See that these are my charges. So electric field due to Q will be in upward direction, isn't it? Ah. Due to C, it will be in upward direction. And due to D also, it will be in which direction? Upward direction. That is going to be my electric field, isn't it? These are my two electric fields. Now, you see that this is 4 and this is 3. So this angle is 37 degree or not? Okay. So if that is 37, if I take a horizontal over here, okay. If I take two horizontal and or horizontal and vertical components, then this angle is going to be how much once again? 37, and this angle is also 37. So only the innate component which is over here as E sine 37 will be left or not. So electric field at B is simply nothing but twice E sine 37 because cos components are going to be getting cancelled. Are you able to get me? And the distance over here is how much? Root under 3a square plus 4a square. So 3a square is 9, 16a square. That means it will become 5a or not. Hypotenuse will be 5a. So EB will be the electric field due to any of the charge distance is same, charge is also same. So 1 by 4 pi epsilon naught. Mhm. Okay, 1 minute. So 2 into 1 by 4 pi epsilon naught into q by this will be d square means 5a square, right or not? And sine 37 is what is that? 3 by 5. Got it? So this is your E at B. So that is just solve it and you write it. Are you able to get me or not? Is that clear? Then potential at B, I have to find out. No need to take the direction. So potential at B will be potential due to charge C plus potential D, which is 1 by 4 pi epsilon naught common. Q distance becomes 5a. So Q by 5a means this distance is 5a from this charge or not of this point. So Q by 5a plus Q by, so this becomes uh, twice Q by 20 pi epsilon naught a. Are you able to get me or not? Is this clear? Next question. If a charge minus q and mass m is placed on the point A, then find F net and its potential. Means I'm placing the charge over here as minus q, isn't it? Acha, so look over there. The electric field at point A due to two charges is how much? Zero, isn't it? So whatever another charge I place it, whether it is positive or negative, it's a neutral point or not. Yeah, basically that point is a which kind of a point? Point A is our null point. So if it is a null point, then what will happen? Net force over there of any charge. Let's suppose if I put it minus q into electric field is how much? Zero. So F net will become how much? Zero. Whether it is positive charge also, F net will become how much? Zero, because at that point electric field is itself how much? Zero. Are you able to get me or not? Is that clear? Next thing it is asking that find the potential energy. So yesterday I gave you, day before yesterday, like I told you that relate potential energy when there is a moving charge as potential at any point with the charge which is moving, isn't it? That is potential energy. VP is potential. Word or not? So potential is equal to charge and the potential at that point into the charge which is moving. So always remember apply this concept. Find the potential at that point and the charge you moving, you know it. So directly write the formula over there. Word or not? So potential energy will be or potential energy over there will be potential at point A into charge which is moving which is minus Q. Are you able to get me or not? So potential at A we have calculated already. This is this term which is Q by, so it will be minus Q square by 8 pi epsilon naught A. Are you able to get me or not? So it is Q1 now. It is minus Q. Okay, take it. So minus Q square 8 pi epsilon naught A. That's my potential energy of point A. Are you able to get me or not? Similarly, if someone would have put it at B, the potential energy means find the, you know the potential at point B and then multiply with the moving charge, you will get the potential energy at point B. Are you able to get beyond? Definitely, definitely. And the force experience will be Q into E. You have calculated, multiply with the charge which is moving, and then you will get the force. So that's why is this process becomes very handful that when we just apply the particular concept of electric field and potential, the things are very easy to calculate. You have seen that. Are you able to get me or not? Now, the question is third question, which is very important. Find the work required to move the charge from A to B. I'm moving a charge, this minus Q, from A to B, and then find the work required. Now you know that I have already told you earlier also. Whenever you are going to find the work or something like that, in these kind of cases, you have to use the concept of conservative field. Void or not, work done by all the forces. Void or not. So to move a charge, I need an external force over here or not. So work done by external force plus work done by, since there is electric field, so there will be work done by electric field also, and that should be exactly equal to change in kinetic energy because the charges does not have mass. We are not considering. Okay, means it has mass, but we are not considering it is moving in gravitational plane. Are you able to get me? Now, the first thing you need to remember, if nothing is mentioned in the question, then remember that charges are moved slowly. How charges are moved? And remember that one thing I'm telling you, these are most important things. Okay, I'll take a page actually. We had the charges and then this is Q, this is Q. The distance between the charges is 8 and I'm moving till 3. This was the concept, isn't it? Now, remember that I moved a charge which is minus Q from A to B. तो ध्यान से देखो पॉइंट याद रखना फर्स्ट थिंग इज देयर आर टू वेज टू मूव द चार्ज when the charge moves slowly and when the charge moves faster. अगर चार्ज को फास्टर मूव करेगा then it will be definitely mentioned in the question, word or not. Otherwise, if it nothing is mentioned, then remember that the charges are moved slowly. How charges are moved? And slowly means their velocity remains constant. Are you able to get me? So we have the equation of work done by external force plus work done by electrical field. That should be equal to change in kinetic energy. So this change in kinetic energy becomes how much? Zero, because we are considering that the charges are moved slowly. Are you able to get me? Now, simple. So work done by external field will be exactly equal to minus of work done by electric field. But what is minus of work done by electric field? That's just negative of change in potential energy, because electric field is also is a conservative field, isn't it? मेरी बात समझ में आ रही है? So change in potential energy means U final. That means U at B minus U at A. I have to calculate. Are you able to get me or not? So U at B, you know the potential at B, it is twice Q, and I have the charge as minus Q, isn't it? So U at B will be V at B into my charge minus Q, and minus U at A means V at A into charge minus Q. So I can take the charge minus Q common, isn't it? And VB minus VA. VB is 2Q by 20 pi epsilon naught A. I'll just write in terms of KQ, void or not. So it is twice 2 by 5 KQ by A. Are you able to get me or not? Okay, minus this is potential at A is 1 by 2 KQ by A. So you can solve this easily, isn't it? You just solve this and you'll get the answer of work done by external force. So it will be how much? Minus of Q. KQ by A also common. So this will be Q square. I'll write this. KQ square by A. And this is 5 twos are 10. So 4 minus 5. So this answer is uh, 1 means KQ square by 10 A. That's your answer. That's my work done by the external field. Are you able to get me? Then, yeah, means then there is some another. Yeah, you have to consider over there. How? Yeah. If they start to move fast, then you have some another extra force, right or not? Okay, so no, no, means some another rocket kind of engine, some another external agency is there which is accelerating the charge, right or not? If velocity changes, that means what? Acceleration is present. So for that, I need to consider net change of kinetic energy to be not equal to zero. Okay. So we did this. Now I'll do one more question based on this kind of geometrical. Would regulate suppose. So we found out the electric field of the rod on vertical scale, isn't it? Like we did for this kind of calculations, like for somewhere over here, isn't it? Today I have a rod and it is placed axially, and this rod has charge plus Q, and the length of the rod is L. Right or not? and this rod is my fixed rod. Okay. Okay, let me write it on one end. It is a which kind of a rod? Fixed rod. Now, at some distance away, that is this point P, void or not? Question is find E and V at point P, which is located at, okay, let me just erase this, mark it perfectly, which is located at exactly R distance away, void or not? Second question, if a charge Q and mass M is released from point A, sorry, for point P, from point P, then find its velocity when distance becomes 2r from one end of rod. Okay, from end of rod. बताओ. What will be your answer? Find the electric field. First question. Find the electric field and potential at point P, and then find what will happen if the charge is released from point P. So it is a continuous body or non-continuous body. So you have to apply the concept of continuous body. Okay. Just like we did for the rod, you have to apply always the concept of continuous body. Means you have to always see the generalized idea was what? To find the electric field, I need to consider dq, isn't it? So consider a dq first. Generalized idea of continuous body. Identify always. Remember that always you have to work on identification. If it is a continuous body, you can't solve normally. You have to definitely consider dq. Okay. So look over here. I'll show you how to do. Just consider a charge, a small charge in this. Right or not? Which is which has charge amount how much? Dq. And the length how much? Dx. Dx. Small length is there now. And that is located from x distance at point P. Okay. So then this due to dq, I'll have a small electric field. That small electric field will be k dq by x square, isn't it? Isn't it? And then the second step comes. You identify that rod is which kind of a geometry? Rod is a linear geometry. For linear geometry, we have only one formula, lambda. Lambda is equal to bada charge by bada length, and that can be written as a small charge by a small length. So here a small length is what? Our dx, isn't it? So lambda is not given to you, but charge is given now. So dq can be written as what? Q by L into dx. Are you able to get me or not? So the electric field, in a simple terms, give me a minute. This is a small dq, sign is same. So electric field over here becomes what? K capital Q by L into dx by how much? X square. That's my electric field, isn't it? Uh, But is lambda is mentioned to us? No. So when lambda is given to us, then we will consider lambda. Otherwise, we will not consider lambda. Okay. So this becomes what? Simple QQ by L dx by x square. Next question we'll do based upon lambda only. Okay. So this implies that if I want to find E net at point P, there are such so dq's. So electric field E net will be what? Integration of all these quantities. So integral kq by L will come outside integral dx by how much? X square, isn't it? So, but the x varies from where to where? It is appearing from one end till this end or not? The charge varies from there to there or not? So this end is how much? It is at r plus L distance, isn't it? And this distance is just r, isn't it? So the integration also must vary from r to r plus L. Are you able to get me? Is that clear? Got it? So dx by x square is how much? It will come as, remember that always I'm giving you one formula, 1 by x square dx is just minus 1 by x. If you solve it, you will get the same answer. Okay. So k q by L, it will be minus 1 by x, and that is r from r plus L. So electric field at point P is very simple to calculate, and it is electric field at axial point. That was my equatorial point at r distance, and this is my axial point. Are you able to get me or not? So it is written as kq by L 1 by r minus 1 by r plus L. Are you able to get me or not? That's your formula. Is that clear? 1 by r minus, that's your formula, where r is the distance of one end and L is the length of the rod. Okay, is this clear? So we got our electric field. Similarly, you try to find the potential. Tell me what will be the potential. What will be the potential? Achha, many people will think that the potential is 1 by 4 pi epsilon naught q by r, but actually that q is spreaded over here on this whole rod or not. So once again, I'll have to define my potential for a small charge, void or not, because for full charge I can't define my potential. Okay, so potential will be, once again, I have to define first dV, because the charge is not at one point. So dV will be 1 by 4 means k into a small charge which is dq and which is located at distance x or. So k dq by x. So what is dq? K q by L into dx by x. Are you able to get me or not? But then what is this implies? V net is how much? Simple integration of this whole quantity. So kq by L will come outside. Integral of dx by x. But x varies from once again r to r plus n. But one thing is there that you know that integral 1 by x dx is not written as x to the power of minus 1 और उसका integration करेंगे. It is written as ln x. What it is written as? Yeah, this is the formula. Okay, मालूम है? Okay, so then V net is simply kq by L ln x, and that varies from r to r plus L. So it can be written as what? kq by L ln r plus L minus ln r. Right or not? Yeah, so it becomes what? This is log a minus log b, which is log a by b. So V net is kq by L. Kq by L. Okay. ln modulus r plus L divided by r. So that can be written as 1 plus L by r. Yes, that's your potential at point what? P. Or we call it as axial point. Are you able to get me or not? So remember this formula. You have to learn it. You do not have to just derive it in the exam. Write this. Make the notes of this formula. So here we defined our potential at the axial case for electric straight rod, and there are three different cases. Tomorrow there is an assignment for you. The three different cases, like derive the potential for this point is what? Potential for this point is what? Potential for this point is what? And potential for this point. So all these four cases I want the potential, and then you write a formula of the like a note that is straight rod, axial, equatorial point, the potential and electric field at all those different cases. In the case of our this particular straight rod, this will be only one case because this is not going to be infinite. Are you able to get me or not? Okay, got the idea? Now you have to repeat the same thing when a charge is released from point P and it goes to distance of 2r. You have to find the velocity of it, isn't it? Got it or not? So I'll once again draw it. Contact pencil. I have the charge. Should I just delete? I'll just take this image. So I have the point P over here, and this was my distance x. And this distance was r, isn't it? And this was r plus L. Now the point is from this end, if the charge goes to a distance of 2r, what is its velocity you have to calculate? Right or not? It goes to from point P to point Q, capital Q, and this is 2r, and this is my r. Are you able to get me or not? Find what is its velocity. Achha, here it is released, isn't it? So if I release a charge from here, the word released means the velocity over here is how much? 0. It's asking the velocity at point, velocity of charge at point Q. Right or not? If the charge released is Q1. Right or not? Okay. Then how to do it? Think, do it. Of course, you have to use the work done. Whenever the concept of velocity energy comes, use the formula of work done. That's easy for us or not? Okay. So you can use force also, like you can find the force, and force is equal to Q into E, and then you know that M A, like force is mass into acceleration, which is Q into E, and acceleration here velocity. See, look over here. Here velocity will be little bit more lay means what will happen, that velocity will vary over here. Right or not? So M, you can use the formula, and here velocity is varying with respect to position. So you can use V dV by dx is equal to QE, and then you can solve it. But that's a tedious task to do. Okay. Yeah. So you will use the work done. Okay. Acha, here only one force is working now. That is work done by the electric field, isn't it? Because on the charge, the electric field is in this direction. There is no external agency, no. So, as we know that electrostatic force is a conservative force, isn't it? So if it is a conservative force, so work done is simple. We know that if it is a conservative force, so change in kinetic energy means we can write now that equation, that kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. है कि नहीं? So kinetic energy finally is half mv square, isn't it? Potential energy finally is the charge which is moving q, and potential at q, if I can calculate, so that is my potential energy final or not. Kinetic energy initially it was 0, and potential energy initial is q into potential at point A. Are you able to get me? Sorry, potential at point P. Right or not? So this is, but work done is change in kinetic energy. But what is your work done? You have to calculate your work done or not. That is force into displacement once again. So work done is equal to change in kinetic energy. You'll have to use this formula of force. Okay. But we know that if it is a conservative force, then I can apply energy conservation or not. Because no another external agency or no other forces are there now. So this implies half mv square plus q. V at q, potential at q is kq by L, ln r plus L divided by r, isn't it? And potential at P, oh sorry. I have to use here, the distance becomes 2r or not at q. So equation will be same, 2r plus L divided by how much? 2r. Got it or not? And that will be q, kq by L, ln r plus L divided by L for point P. Are you able to get me? So equation will be half mb square. I can take k. So इसमें भी तो स्मॉल क्यों ही है ना, साइन सेम रखते हैं यहाँ पे. Okay, k into small q, k into small q. So kq square by l. My goodness, ln 2r plus l divided by 2r minus ln r plus l divided by l. Void or not? So log a by log a minus log b is log a by b, isn't it? R plus l divided by r. Why I'm writing l? Sorry. Take. So that is equal to how much? Half mb square is equal to kq square by l. That's why I told you. Now you think how much hard it would have been to follow this equation. कितना integration करना पड़ता है कि नहीं? So this becomes ln 2r plus l divided by 2r divided by r plus l, means इसको multiplication में मैं लिख दे रहा हूँ, divided by r into r divided by r plus l. यही हो जाएगा. So you look over there, r and r got cancelled. So equation is, this implies that you can just write it. Okay, means you just solve it. I'll not solve it fully. You write the answer after this. Why or not that v square is equal to twice m, you take the root over there. Okay. So this is your velocity of charge at point Q. Right or not? Is that clear? चलो एक बार देख लो फिर से, then I'll move ahead. Can I move? So these were the concepts. Okay, means if I release, if I just do it. Now here you got to know. Uh, I'll not ask about the charge, but here you got charge in the rod and all. Right or not? That Q is given. Now I'm giving you a question for your homework as assignment. That if in this rod, okay, the length of the rod is L, and the charge varies like, the density actually varies. It varies like lambda is equal to ax plus b coulomb per meter. Good or not? Inside the rod. Okay. Then find the electric field at point P at a distance r. Good or not? Then find the electric field and potential at point P. Got it? आगे बढ़े. 1 minute. चलो. Now look over here. So this is your question you tried. This is your homework. And tomorrow I'll tell you the answer. Okay. Okay. So now look over here. I'm giving one more question. Let's suppose if I have a charge Q of mass 2n, word or not, and another charge is there This is my Q1. Okay, write it as Q1. And then there is this another charge. 1 minute. Q1 and mass 2m. And then there is our another charge Q2 and mass m only. Charge Q2 and mass how much? M. Right or not? They are placed on same line, which has a distance between them as r. Question is very simple. Q2 is released from rest. Q2 is released from rest and Q1 is fixed. Q2 is released from rest and Q1 is fixed. Find the speed of Q2 after long time. Find the speed of Q2 after long time. Second question, both Q1 and Q2 are released. Both Q1 and Q2 are released. Then find their speeds after long time. बहुत अच्छा क्वेश्चन है ये, है ना? Try to do it. Then you tell me what will be the answer. What? Of course, you have to use something like that. Hmm. Think and you can utilize this. If you think, then it will be very, very easy to understand. Okay, do it. Should I do or you can do it? Hmm. You have 2 minutes, last 2 minutes. देखो, so you look over here. How to do it? Achha, what do you mean by getting the idea that they are means they are asking about the velocity after long time, isn't it? So, in your mind, what does it mean by something when we go to long time case? Can you tell me? What is meant by long time? No? So, it's easy. Hmm. What's the meaning of long time? Then I'll tell you. Long time means infinite time. Acha, at infinite time, if the charges will be nearer to each other, they will not be, na? Infinite time means what? The charges will not be nearer to each other. So they are at too much far distance away. Got it or not? So this is what you have to always understand when we talk about the word long time. Okay, if it says long time, okay, means after long time. Remember that distance tends to infinity. Got it or not? Okay. So if distance tends to infinity, beta, only one force is working now. That is electrostatic force. So work done by electrostatic, and this electrostatic force is a conservative force. So kinetic energy final, first case I'm solving, plus potential energy final is equal to kinetic energy initial plus potential energy initial. उसको बोलो है ना? Final kinetic energy I have to find, which will be half mv square. Final potential energy at infinity, potential energy becomes how much? At R, potential is zero or not? Yesterday I thought, na? So it will be what? Q2 into potential at infinity, isn't it? Kinetic energy initial is zero. Potential energy initial will be what? Q2 into potential at point 1. Hold on. So this is zero once again. So what is my equation? Half mv square is equal to Q2 into 1 by 4 pi epsilon naught Q1 by distance R. Are you able to get me or not? Is that clear? So that implies V is equal to root over, what will be that? Twice K Q1 Q2 by m. That's my velocity after long time. But this is when one charge is fixed. What happens when both the charges are moving? Check that. Tell me what will be the answer. Imagine what will happen if both charges starts to move. बताओ. Any idea to do that? We can't use the same. We can't use the same. Why? Listen, listen. This is a very nice thing to understand. अच्छा एक बात बताओ, when both charges are released, okay, this was my Q1 and this was my Q2 separated by some distance R. When both are getting released over there, then see, initially means this Q1 will move towards this side and Q2 will move towards this side, or yes. Now their masses are 2m and m respectively. So how they are moving? They are moving with such some kind of an impulsive force which is acting at that instant of time. Yes. Now look over here. You see that first thing you need to remember that they are moving with respect to that this impulsive force which is called as Coulomb force. Are you able to get me? But look over there that this net force on the system, although the Coulomb force is throwing them out, the net force on the system is how much? Zero. So when they are released, let's suppose their velocities were v1 and v2. So their velocities are actually interrelated after long time also and before the long time also. Right or not? Okay. So initially they were at rest. Finally they have velocity v1 and v2 or not. So can I, if net is zero, can I apply initial momentum is equal to final momentum? So two things you need to keep in your mind. First thing is that when one charge is fixed, the finding kinetic energy of another charge is very easy. But when both of them are released, it's just like a collision. When two balls are brought together and they collided, after the collision, they're moving with some velocity. Are you able to get me or not? So remember, when both of the charges will be released, it will be behaving in such a way that they are actually an object which has collided with each other. Are you able to get me? So initially both of them were rest. So initial momentum becomes zero. Finally, mass 2m has velocity v1 and q2 moves towards this side. So minus m into v2. So we got the relation of v1 and v2 that twice v1 is equal to v2. Are you able to get me or not? Is this clear? Got it? But but still the answer is didn't have came. Now we will apply the work energy theorem. That kinetic energy final for second case plus potential energy final is equal to kinetic energy initial plus potential energy initial. Got it or not? So final kinetic energy is equal to half twice m. दोनों के पास kinetic energy है, so half m twice m and half m v 1 minute. M के पास v2 है ना, half, so half m v2 square. Final potential energy is always zero. Initial kinetic energy is always zero. But initial potential energy is still going to be same because they were at rest over there, isn't it? Which is k q1 q2 by distance. How much was that? R was my distance, isn't it? So you just put it. Now you replace one of v1 or v2. First time you replace v1, second time you replace v2, and then you will get the velocity v1 v2 after long time. Are you able to get me or not? Got it. So this is the way how you solve it. Okay. So always remember this is the way how we are going to solve it. Right or not? Chalo. Should I take one more question now? Okay. Uh, okay. बोल रहा है. Today we are learning unorthodox questions. Okay. And I'm trying to relate as much as possible electrostatic potential and work energy everything. Right or not? So बोल रहा है कि there is one charge plus q which is fixed. Right or not? Okay. 1 minute. Yeah. Now, another charge, okay, of same unit was released with some velocity, okay, was released with some velocity from infinity. This charge has plus q charge and mass of the charge is also m. And this is at infinity right now. Right or not? Okay. Now these two charges are positive, isn't it? So when it will come, it will stop at some distance over here, isn't it? It will stop at some distance. So question is very simple. If initial separation was infinite, previous question we did when the charges were going till infinity. Now the charges are at infinity. Go ahead or not? Is at infinity. Find the minimum possible separation. Find the minimum possible separation between them. Good. Means after coming here, somewhere over here, that somewhere at r distance, its velocity will become zero, isn't it? Okay. So I want you to find that what will be this r minimum. You have to calculate that what can be the r minimum where the velocity will be zero. And one is fixed. Okay. You do it. 1 minute. I'll just take a break. हेलो. हो गया कितना आ रहा है? करेक्ट. वेरी गुड. तो क्या लगाया? एनर्जी कंजर्वेशन लगाया. Very good, very good. So you have to apply only in these case of cases energy conservation. And means if one of the charge is fixed, directly energy conservation. If none of them are fixed, first momentum equation and then energy conservation. Why not? Okay. So energy conservation will say because after energy means you have to apply the concept basically. Why I am applying momentum conservation is because their velocities are interrelated. Why or not? Both of them has velocities, and the net force is there. So directly from momentum conservation I can apply energy conservation. Okay. So here energy conservation only. So kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Kinetic energy initial is half mv square. Initial is zero, isn't it? Final is zero over here, and potential energy final is charge which is moving q and potential at point r, isn't it? Which is q into uh, k cube by k cube by r, isn't it? So v is equal to root under twice kq square by. Acha, it is asking r minimum now. Yeah, so twice kq square by mv. That's my answer. Word or not? Acha, let us do this same problem, but this time, let's suppose if I have the charge plus q. Okay, I'll put not plus q. I'll put a random value. Let's suppose the charge is plus q1. Ah, and okay, 1 minute. So the charge is plus q1 and mass is m. Word or not? Okay, and somewhere from infinity means this charge, the another charge has came nearer to it. Yeah, it came from infinity. Why or not? And it means this charge q2 is released from infinity with some initial velocity u. Why or not? Okay. So बोल रहा है same question if none of the charges are fixed, if initial separation was infinite, find the minimum possible separation. Find the minimum possible separation between them. बताओ. Both the charges are going to be moving. Yeah. The masses are also different. M1 and M2. Okay. Mhm. Velocities, you think what will happen? एक सिंपल सा आइडिया, एक सिंपल सी लॉजिक, एक सिंपल सी लॉजिक है भाई। दोनों चार्जेस रिलीज किए गए, ठीक है, मतलब वन वाज एट रेस्ट इनिशियली एंड वन वाज रिलीज फ्रॉम इंफिनिटी विद सम इनिशियल वेलोसिटी। एक तुम खुद सोच के एक बात सोचो, मिनिमम सेपरेशन विल अकर, when will be the minimum separation which will occur? They are both feeling the repulsive force when they will be closer, isn't it? So minimum separation will occur when both charges moves with same velocity. So minimum separation will only occur when both charges will have similar velocity, got it or not? Because they can't come closer more than that, because they both are at what we say, both are at uh, basically uh, basically same charges, and both are feeling the same repulsive force. Are you able to get me or not? So they will have the particular minimum separation when suddenly they will have same velocity, got it or not? Because after that, once again, the bodies will start to feel forces of separation, and they will once again feel separated, void or not, because after that they will feel too much repulsive force. Okay, are you able to get me? So look over here. So applying momentum conservation, we know that when both are not fixed, so I have to use momentum conservation first, because f net is 0, isn't it? So if f net is 0, initial momentum is m2 into u will be equal to final momentum. Both are going to move with same velocity. Are you able to get me or not? So initial separation occurs when the velocity of both of them is exactly equal to m2u by m1 plus m2. That is NEET 2017 question. Right or not? Second thing I have to take care of. Uh, After that, I can apply energy conservation also, isn't it? So energy conservation, we have first thing, kinetic energy initial is kinetic energy final plus potential energy final is equal to kinetic energy initial plus potential energy initial. So final kinetic energy, both of the masses moves with common velocity or not. So both has kinetic energies v square. Final potential energy will be the charges which are moving, means consider anyone to be at moving. So I will consider q1 and potential between them at minimum distance, isn't it? Are you able to get me? And that is equal to kinetic energy initial, which is half m2 into u square plus potential energy initial, which is 0. Are you able to get me? So equation is what? Simple. I'll write q1 into q2 kq, k I'll write over here, divided by distance r minimum. Are you able to get me? That is exactly equal to half m2 u square minus half m1 plus m2 into v square, which is m2 square u square divided by m1 plus m2 ka whole square. So you solve it, this one and this one get cancelled. So when you will solve it, basically, you can solve it or not. I'll not solve the whole thing fully. This will come as it appears as r minimum will be exactly equal to, I'm writing the formula directly, okay? So when you solve, the r minimum appears as twice K Q1 Q2, okay, into M1 plus M2 divided by M1 M2 into US square. That is going to be your R minimum. Are you able to get me or not? Is that clear? Okay, that's going to be your R minimum. Okay. Okay, so do we do one more question based on this? Okay, so I want to give this question as a homework to you. One second, second type of question as a homework. Let's suppose there is a charge q of mass m, and here there is a plus q charge. Okay, plus capital Q. And this charge is my fixed charge. Got it or not? So now you see that they have two lines of motion. So this distance between them is given, which is exactly equal to distance d. Okay. Now, if the charge of these point charge is released with some kind of velocity v towards our capital Q, then find the closest distance of approach. Right or not? Are you able to get me? So you keep in your mind always that closest distance of approach is these kind of things also, like till where it is approaching. Right or not? Because after that the separation will start becoming bigger and bigger. Are you able to get me or not? So whenever there is a question of closest distance of approach or R minimum or initial separation, then you use always energy conservation. What do you have to use? Energy conservation. Are you able to get me? Okay, ठीक है. तो ये these were all our different types of questions related to electric field, electric potential energy, and all this kind of things. Right or not? Okay, now the point arises. See, I'm going to do all of these ring, disc, and all later on. Okay, but before that, I'll establish everything. So now give the heading. तुम सोचोगे कि सर ये तो एकदम बुक से मैच ही नहीं कर रहा हो. How you are teaching is not matching with book only. So it's never ever going to match. I'm just going to establish everything and then I'm going to do all the things. Okay. So relation in electric field and potential. Written down. Okay. ठीक. चलो. तो हमें सबसे पहला चीज पता है कि वर्क डन. If I write work done, then work done is equal to integral minus of f dot dr. What? So not minus. Sorry, why I'm writing minus? Integral f dot dr. That's my work done. But work done is equal to change in potential energy or negative of change in potential energy. So change in potential energy will be what? Minus of integral f dot dr or not. So this means that I can write for conservative forces, we know that force can be written as minus of this will change to du by dr or not. If I just bring this dr towards this side, actually this thing, see, potential is a scalar quantity and r is a vector quantity. So this is denoted by a sign minus delta u. This is known by a name which we call it as gradient. क्या बोलते हैं इसे अपन? हाँ, इसका मतलब होता है that this d by dr vector is a vector quantity, got it or not? So which can be represented as minus of d by dx I cap plus d by dy j cap plus d by dz k cap. These all three things will be there at the same instant of time, or and that is multiplied by u. So that is what is called as gradient. Are you able to get me or not? Okay. So remember that. See, this is a formula. You have to just remember it like a formula that I'm writing d by dr vector, but r can take three different values x, y, z, and potential is a scalar quantity. Potential energy is a scalar quantity. So that is why it is given a vector form that it is can be called as a gradient vector. Are you able to get me or not? So this is why this is written as minus of du by dx I cap. This is what I taught you in work for energy, isn't it? And du by dz k cap. But this is only for which kind of a field? Conservative field. किस field के लिए है बेटा? Because for only conservative force, the work is equal to negative of change in potential energy. Is that clear? Now you look over here. We know that the force is written as Q into electric field E, isn't it? And potential energy is written as Q into potential energy, potential at any point. Yes. So I can relate electric field and potential also or not. How? I can write Q into electric field E is equal to minus Q will be common and it will change to dV by dx I cap plus dV by dy j cap plus dV by dz k cap. Isn't it? V for potential, and that is why we give this electric field formula, that electric field is also given as minus dV by dx I cap plus dV by dy j cap plus dV by dz k cap, and which is nothing but minus of delta of potential, isn't it? And which can be written as minus of dv by dr vector. अरे कुछ तो बोला हाँ या ना? So see, you got the analog of force. See, that day I told you the force is created by field. So when we talk about the respective charges, we need to talk about single charges. So for understanding of single charges, the force can be analoged with electric field and potential energy can be analoged with the potential, right or not? And that's why we create this formula that for single charge, electric field is going to vary as minus of dV by dr. Are you able to get me or not? Minus of dV by dr means how the potential is going to vary with respect to r. Electric field will be the negative of that. Is that clear? Means wherever the change in potential is maximum, at that point the electric field will be minimum, and whenever the change in potential is minimum, at that point the electric field will be maximum. Are you able to get me or not? Is that clear? So now look over here. Basically I can bring this dr over here, and then change in potential is given by formula minus of integral E dot dr. So how many equations we got? We got around two more equations of conservative electrostatic field, and these are developed by Faraday. Got it or not? And that's why they plays a very big role in our understanding. Got it? Is that clear? So let us just understand this equation delta V, which is very of important concern to us. Okay? So we write delta V as integral E dot dr, isn't it? That means E dot dr means this is this is my electric field and this is my dr vector. So some kind of angle can also be created between electric field and dr vector or not, and then we are defining the potential at that point, isn't it? So there are cases for this angle. So first case, if theta is theta between E and dr is acute. Sorry, I forgot to point one thing. Here it is minus is acute. ठीक है, समझना जरा. ओके, सो अगर थीटा एक्यूट है बेटा, तो cos theta is positive one, isn't it? So this implies that change in potential is what? Negative. And yes, because E dot dr will be positive or not if theta is acute. So this implies that our potential decreases in the same direction of electric field. Means, let's suppose if I move like this way, if the electric field is increasing in this direction and distance is also increasing in that direction, then the potential will decrease in that direction. Are you able to get me or not? Yeah, so when you take the same direction of electric field and dr, the potential will decrease in that direction. Are you able to get me? Next, second case, if theta is between E and dr is obtuse, then this implies that delta V is what? Positive, which implies V increases. Are you able to get me or not? So in opposite direction, let's suppose if the electric field is in this direction, opposite direction of electric field, our potential will increase. Are you able to get me or not? Yeah, in the opposite direction of electric field. And if theta is 90 degree, then this implies, so ऐसे लिखो, sorry, अच्छे से लिख लेता है, theta between E and dr is 90 degree. Then delta V is how much? Zero. Means change in potential is zero. Are you able to get me or not? Is that clear? So that's what our conclusion is, that in the direction of electric field, the first thing is potential decreases. Go ahead or not? Second point, in opposite direction of electric field, the potential increases. Got it? And in perpendicular direction, of electric field, the change means, this implies the potential remains constant. ठीक है? Are you able to get me on? And this is what is called as equipotential surface. This statement means in perpendicular direction of electric field, our V is constant or not? So this generates, like, if V remains constant, this generates the concept of equipotential surface. क्या जनरेट करता है, किसका कॉन्सेप्ट? Equipotential surfaces. Are you able to get me or not? Is that clear? Is that perfectly clear? Okay, so just tell me this question. Let's suppose if I have electric field going in this direction. Okay, and I selected three random points A, B, and C. Options are option A, potential at A is equal to potential at B is equal to potential at C. Option B, potential at A is less than potential at B is less than potential at C. Option C, potential at A is more than potential at B is more than potential at C. Option D, potential at A is more than potential at B is equal to potential at C. बताओ क्या होगा? If the lines represents our electric field. What will be your answer? Mm-hmm. Think. अच्छा एक बात. Right now we got in the direction of electric field potential energy. The potential decreases, isn't it? So if I consider A and B, so potential of A will be more than potential of B. First thing is very clear, isn't it? So potential at A is more than potential at B. In the direction opposite means perpendicular to the direction of electric field. The potential remains same. So B of B is equal to B of C. Option D is correct. No? B of A will be more than B of B is equal to B of C. Are you able to get me or not? That's your answer. Remember like this way always. Okay, potential decreases in the direction of electric field. Potential remains constant in the perpendicular direction of electric field. Are you able to get me or not? I'll once again say potential decreases in the direction of electric field and potential remains constant in the perpendicular direction of electric field. Wait a minute. Is that clear? Sure. Let us do one more question. बोल रहा है कि if electric field is given as 3x square I cap plus 2y j cap, then find v at 1 comma 2 comma 3, and if बोल रहा है if v at 0 comma 0 comma 0 is 0 volts. Bravo. You think what you have to do it fast, but tell me. बताऊं? अच्छा, electric field, first of all, we know that the relation is change in potential is minus of integral E dot dr, isn't it? Then we see always the electric field vector, right or not? If it is a vector quantity, then the thing is, see over here, 3x square I cap, what is my electric field? 3x square I cap plus 2y j cap. Then you have to take the dot product with the dr in the form of vector quantity, which is dx I cap plus dy j cap plus dz k cap, right or not? So it will become what? Change in potential, that is V final minus V initial, is equal to minus 3x square dx minus 2y dy, because I dot I is 1, j dot j is 1, others are 0, isn't it? And I'm going from where to where? 0 to 1 for x. Look over here. X I'm going to 0 to 1, and y I'm going from 0 to 2. Right or not? And initially at 0 comma 0 comma 0, this is 0. So V final is very very simple. Integral minus 3x cube by 3. I'm writing it directly. Okay, 0 to 1. You know the integration now? Minus 2y square by 2, 0 to, right or not? So this and this got cancelled. So answer is minus 9. Sorry, minus 1 and minus 4, which is minus 5 volts. That's your answer. Got it or not? Is that clear? One more question you try it. बोल रहा है if E is equal to 8 by r square r cap, then V at 1 comma 2 comma 3 if V 3 comma 4 comma 0 is 0. Now you do this question. So we did how many questions today? Okay, from here we started doing. Do it fast, do it fast. I have a very less time. क्या होगा आंसर? Should I do? अच्छा देख, सिंपल सी बात है, यहाँ पे आर स्क्वायर के फॉर्म में दिया हुआ है ना, तो डेल्टा v is you have to think always minus integral e dot dr is there. So why to change r? Do not change r. Okay, if it is in form of r, use the dr form directly. So delta v is equal to minus 8 by r square r dr. Right or not? So I have told you 1 by x square dx integration is minus 1 by x, isn't it? So this will be what? And consider it from r initial to r. Fine. R initial potential is 0, so just v final I'll get. So v final will be minus plus 8 1 by r final minus 1 by r initial है कि नहीं, यही होगा ना? अच्छा अब देखो, यहाँ पर अब ध्यान देना, हमारे पास r फाइनल है और r इनिशियल है, तो ये तो कोऑर्डिनेट्स है ना, तो व्हाट इज r फाइनल? r फाइनल इज नथिंग बट रूट ओवर x फाइनल स्क्वायर प्लस y फाइनल स्क्वायर प्लस z फाइनल स्क्वायर, यही तो होता है ना। तो बस यूज करो 9, ये कितना हो गया, 9 4 13 1 14, so this is root under 14, and this is how much, r initial root under 3 square plus 4 square, which is 5. So answer is 8 bracket close 1 by root under 14 minus 1 by 5 volts. That's your answer. Solve it. Got it or not? Okay. मजा आ रहा है? Okay. Now give the heading. Last topic of today. And we have done all the relation of electric field, work, potential, everything. We related everything over here. Means there are four quantities in the whole electrostats which confuses everyone, and we related today that whole thing. We related how the work, force. Remember that there are four things: electric field, electric potential, energy, and then their variation like E is equal to minus dV by dr, and force is equal to minus du by dr, and then comes at the end the last point which we call it as electrostatic or equipotential surfaces. Word or not? So this the concept of equipotential surfaces right now only we had generated, like we got to know that in the direction of perpendicular electric field our equipotential surfaces are there, isn't it? Okay. So, 1 minute. Just, just do not disturb. Open do not disturb. So give the heading. Equipotential surfaces. ठीक है, आगे बढ़े. So we established that understanding that when the potential, when we consider the perpendicular direction of electric field, in that direction the V remains constant, means change in potential is zero, isn't it? And then we call it as equipotential surface. But let us define it in a perfect way. That what is actually the equipotential surface? It means that नाम से ही समझ में आ रहा होगा इक्विपोटेंशियल मतलब चारों तरफ पोटेंशियल क्या है सेम एंड ऑन द surface. That's all. So at what is the meaning of this? That at every point on the surface, if electric potential is equal, then that surface is called as equipotential surface. Got it? Okay. So look over here. So at every point on the surface, if equipotent means like let's suppose if I just consider our random surface. ठीक है, ये एक सरफेस मान लिया अपन ने, है ना? Okay. Now, at every point, the potential is what? Same. Potential is not varying. ठीक. Look over. ध्यान से देखो. अच्छा, हमने पढ़ा कि सर अगर in the perpendicular direction of electric field, if V remains constant, then we call that surface as equipotential surface. Again. But अभी इतना समझो कि if V remains means in the perpendicular direction of electric field, the V remains constant. है कि नहीं? अरे भाई, तो इसका वाइस वर्सा भी तो पॉसिबल है कि if for any reason the potential is constant, then for that reason the electric field will be perpendicular to it or not. So we defined that we know that delta V is equal to minus of integral E dot dr. So delta V is going to be 0 if the angle between them is how much? 90 degree. If the angle between them is how much? 90. So that means that when the electric field makes with the dr 90 degree, for that reason the change in potential is 0. So vice versa is also possible that sir, for if any reason the potential remains constant for any surface, then for that the electric field must be perpendicular to that surface or not. And that is why we call that surface as equipotential surface. So whenever you have equipotential surface Balak, then the electric field is always perpendicular to it. कैसा रहेगा electric field? Is that clear or not? So let us define in a much more greater sense. Or should I just remain? Let it remain. Okay. So first thing is that. Second point, let us mention some cases. Means the points basically that electric field lines. Second point was electric field lines are always perpendicular to the equipotential surface. ठीक है? Third point, नो टू इक्विपोटेंशियल सरफेस। अब दो इक्विपोटेंशियल सरफेस इंटरसेक्ट कर सकते हैं क्या? नहीं ना, because electric field lines will not be perpendicular, isn't it? So no two different equipotential surface, sorry, no two different equipotential surfaces can intersect each other. Is that clear? Third point, remember that this is very, very important to understand. If work done, take it, in moving a charge, if work done in moving a charge along the surface is zero, then we call that surface as equipotential surface. You got the idea? That look over there, the electric field is in the perpendicular direction of such surfaces. So if I move a charge from this point to this point, so what will be happening? There is no force acting on it. So no work will be done, isn't it? So work done on any moving charge on equipotential surfaces is always zero. Are you able to get me or not? Is that clear? Okay, so let's suppose if I take any point charge, got it? And I just made some charge to sit at the center. Just made the charge to sit at the center. Right or not? So let's suppose the charge, this is positive any plus q. Right or not? So for them, you know that the electric field lines will emerge outward of it, isn't it? That's my electric field lines diagram. Now you see that when I draw the tangent of this circle at any point, say, yeah, you see that these electric field lines are perpendicular to this tangent or not. So for any kind of curvical path, you need to draw tangent for the surface. Is that clear or not? What should be drawn? Tangent. So look over here, when the electric field lines are perpendicular to this tangent, we know that this point, you see that every point the electric field line is perpendicular to the tangent or not. So this whole big circle which we have got, can we term that this circle is a point of equipotential? Means as the electric field lines are perpendicular to this tangents at each and every point of this circle, and these tangents after combining they are forming a perfect circle over here. So these points which we are considering, all these points will be having same potential. क्या रहेगा इन सबके पास? Are you able to get me or not? Is that clear? So always remember that when we have these kind of systems, we will have the particular our charges means all these points will be kind of equipotential in nature. Are you able to get me? Similarly, let's suppose if we take a line charge, okay, जैसे मान लो एक लाइन स्ट्रेट जैसे रॉड ले लिया है ना, लीनियर रॉड, ठीक। तो इसके ऊपर जो चार्जेस हैं, मान लो ये पॉजिटिव 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 होंगी ना, ध्यान से देखना जरा। अच्छा, इसमें नो फिल सिलेंडर है क्या? हाँ, तो लुक ओवर देयर, इफ आई जस्ट think of this particular line charge and when I want to bound it, कैसे बाउंड होगा? ये एक सिलेंड्रिकल शेप में बाउंड होगा, है कि नहीं? How it will be bounded? Like a cylindrical shape, isn't it? क्योंकि चारों तरफ चार्जेस हैं in the linear form, and for every point, every center, what will be this field lines? It will, the field lines will be something like that, which will create a circle for any dq charge which I consider on the rod, isn't it? So look over here. So that means that for different kinds of charge configuration, I will get, see, this was a point charge, isn't it? And this is my which kind of charge? Line charge. So that means that for different kinds of configuration, I'll get different kinds of equipotential surfaces or not. So look over here. If I see that here the equipotential surfaces is cylindrical in nature, isn't it? Because one circle, it's like the coins of circles which are placed like over here, isn't it? So for line charge, what kind of equipotential surface I have? Cylindrical. Are you able to get me? So that is why let us just define our different charges, and for that I'll write the different types of equipotential surface. So let's suppose if I have point charge, the equipotential surface is spherical in nature, not circular only, but spherical, because electric field lines are spherical. Got it or not? Similarly, if I have line charge, the equipotential surface is cylindrical in nature. Similarly, if I have a spherical charge, means a spherical charge system, then I have a spherical equipotential surface only. Okay. If I have cylindrical charge, सही रहेगा ना, cylindrical सही, हाँ, cylindrical charge system, then for that also cylindrical is my spelling mistakes you should ignore, okay? And then if I have plane charge, means kind of a seat, rectangular seat or something like that, then for that equipotential surface is what? Plane. कैसा नेचर रहेगा equipotential surface का? Planar. Are you able to get me? Is that clear or not? Okay, so I'll ask one question and then we'll move ahead. Okay? Or how many things equipotential surface? Okay, so what we will do, we'll stop it over here.